This is a lesson for Chapter 6, Section 4, titled Volume of Spheres. And so, when we're taking a look at a sphere, the formula comes from the cones. And the cone actually has to have something specific. The radius here has to have a height that's also equal to the radius. So the cone's height equals the radius. The cone has a radius here, so these numbers could be like 2 and 2. But they also have to have the same radius as the hemisphere. And so if we took these two cones and filled them with sand or water, and then poured their contents into the hemisphere, it would fill the hemisphere completely to the rim. So what that tells us is that two cones, again having the height equal to the radius, and that radius the same as the radius of the hemisphere, two cones of those sizes will fill one hemisphere. And so what that means is four cones would actually fill a whole sphere. And so what we'll do is we'll take the cone formula here, 1/3 pi r squared times r, and again this extra r here came from the height, because typically the cone formula goes this way, 1/3 pi r squared times by height. But since the height is equal to r, that's why I put r there. So what they did is they combined these two terms, the r squared and the r made r to the third. They still have the pi, and the way they got 4/3 is they multiplied the 4 over 1 times 1 over 3. And so that's how the formula comes about. So let's take a look at some problems. A ball has a diameter of 10 inches, and so what that looks like is if I draw a sphere, the diameter, the distance going all the way across the sphere, from the center of the circle, through a line going through the center of the circle from one curve of the sphere to the other curve. So when we're dealing with diameter, whenever we've got one of these volume formulas, no matter whether it be a cone, a cylinder, or sphere, we always want the radius. And so the radius is equal to half of the diameter, and so that's where I'm getting 5 from. And so let's take a look at the volume formula, 4/3 pi r cubed. So I'll bring down the 4/3 pi, and then r to the third power, so 5 to the third power. And so looking at a calculator, there's a neat little button that allows us to find out numbers to the third power really fast. So typically, since it's so common, they actually have it on the calculator. And so 5 to the third is 125. So now we have 4/3 pi times by 125. So I'll go ahead and take the 125, multiply it by a good approximation of pi of 3.14. That gives me 392.5. And so from there, what I do is I multiply by the 4 and divide by the 3. So watch when I do that. Times by 4, that gives me this number, 1570. And then I'm dividing that number by 3. And so now I'll divide that by 3. And notice how I'm not really clearing the calculator. I'm just leaving the numbers that are in it and then just doing the work. And so that number was 523 1/3. That 3 ended up repeating. And so they want us to round to the nearest cubic inch, so the 3 is not quite big enough to round that up, so we'll leave it as 523 inches to the third power. So let's take a look at the next one. This one gives us a radius rather than the diameter, so it's a little bit easier because there's one less step. We don't need to find the radius. So what we're going to do is start with our volume formula. I always like to start with that because it helps me remember what to bring down and where to put things. And so I'm going to put the 9 in place of the r. And so now I need to cube that number. So we'll pull up the calculator and clear it now and go ahead and enter 9 and then cubed. And that gives me 729. So let's go ahead and write the rest of the formula down. 4/3 pi times by 729. And so this time I'm going to go ahead and I see that 3 goes into 729 since 3 went into 9. So let's see how many times. 3 goes into the 729 when I go ahead and do the division. We have 243. So now I have 4 times pi times 243. So now I'm ready to just go ahead and multiply the numbers. So I have times by 3.14. That gives me 763.02. Then I'll go ahead and just multiply that answer by 4. And that gives me my answer. The number was 3,052 800ths. And so these are inches to the third power. If I was to round to the nearest cubic inch, that's the ones place. The 0 is not big enough to round it up, so 3,052 cubic inches is the answer. So the next problem is one in which they ask for the amount of air displaced when the ball is put into the cylinder. So this air in the cylinder initially, when I put the ball in, it takes up some of the space. And so to find out the amount of air that's displaced would be actually just the volume of the cylinder of the sphere, 4/3 pi r cubed. So we'll go ahead and substitute our numbers in there. So we have 4/3 pi times by the diameter. Well, notice how the distance from the center of the cylinder to the curve is 5 inches. Well, since the sphere touches both sides, I'm going to assume that's 5 inches as well. So that's the number I'm going to use. So times by 5 to the third. So we've actually done that before. That's 125 pi times by 4/3. And so it ends up being the same as this last one, or actually the first one that we ended up doing. And so we'll see how 4/3 times by pi times 125 gives me 392.5. And we saw at the end it was 523 inches to the third power. So again, when we are finding out the cylinder, or the displaced air or displaced water, whatever the liquid or fluid or gas is inside the cylinder when the ball is dropped in there, that's what we end up doing, just finding the volume of that sphere. So let's take a look at the next problem. And here it is. It asks us says, if you triple the radius of a sphere, how does this affect the volume? So let's take a look at the formula, 4/3 pi r cubed, and let's triple the radius. So when we do that, what we're actually doing is we are multiplying 3 times r, but then we have to triple that, or bring that to the third power. So when we tripled the radius now, so when I use the exponent rule, which when we have parentheses, we have to multiply the exponent outside parentheses, so I'm left with 4/3 pi and then 3 to the third power r cubed. So 3 to the third power ends up being 27. So let me go ahead and rewrite what I've got here. So I've got 4/3 pi times by 27r to the third power. So let me just move some terms around using that commutative property. And when I do that, I'll put the 27 on the outside. I've got 4/3 pi r squared, or r to the third power. This is the volume formula that I started with. So when I triple the radius, this is what happens. I get 27 times larger. So tripling the radius would make the volume 27 times larger. So let's take a look at our last problem here. So the last problem is similar to the one where we displaced the air, because we put a sphere inside a cylinder. And what we'll end up seeing is that when we're trying to find the volume after the ball with a hole diameter with the diameter that's the same as the cylinder, ends up going right inside. So we want to find out the remaining volume left. And so this is where we're going to end up needing two formulas. So the first one's the pi r squared times height. This is the volume of the cylinder. And then from there we're going to subtract the volume of the sphere. And so our volume of the sphere formula goes 4/3 pi r cubed. So we'll go ahead and substitute our numbers in there. So pi times by the radius. Now the radius again is half of that diameter. So we're doing 5 squared times by h, which is 10. And then minus 4/3 pi r. Well, r is 5 again. So let's go ahead and substitute that in there. So 5 to the third power. So doing some more work, we've got pi times by 25 times 10, which makes 250 pi. Now I'm going to leave it in terms of pi right now, and you'll see why in just a moment. So I've got 4/3 pi times 125. So I'll leave that calculator. multiply 125 times 4, and then divide that by 3. That gives me this number, 166.6 repeating pi. So the reason I left it in terms of pi is because I need to subtract these two numbers. So rather than coming up with a number with a decimal and then having to subtract another number with a decimal, I'll just subtract the coefficients, those numbers in front of pi. So let's go ahead and do that. So I'll subtract, I'll make this a negative number, and then subtract that. So I made it negative, so now I'm going to add, because when we have opposite signs, we actually subtract. I'll add 250, that gives me this number, 83.3 repeated pi. So now I can go ahead and simplify that, or at least approximate this by timesing this by 3.14, or approximation for pi. And that gives me this number, 261 and 6 repeated, which is 2/3. So if I was to round that to the nearest cubic inch, so we'll say nearest cubic inch, I would look at the 6, and it is big enough to round this up. So I would say 162 cubic inches is the space left over in the cylinder, I'll say. So those are the types of problems that you'll see on that assignment. Good luck.